students, in this video we are going to discuss the problems based on Werner's theory. The secondary valency of cobalt is 6. Calculate number of moles of AgCl precipitated when excess of AgNO3 is treated with 1.5 liters of 0.2 molar COCl3 dot 5 NH3. We have to find out moles of AgCl formed. Here what is the secondary valency is 6. From the secondary valency 6 we will write the structure of this one complex. Complex structure is taken as CO is surrounded by how many 5 NH3, but the secondary valency is 6, so here only 5, so one more chlorine is expected. 2 chlorines are expected outside the complex. So this is the geometry of the complex given. Now you know this complex can ionize to give how many? 1 complex ion and 2 chloride ions. How many chloride ions? 2 chloride ions. Okay. Then this can react with to give AgCl. It react with AgNO3 to give AgCl. Now what about the data of the complex? Molarity into volume in liters into n factors. N factor means molarity into volume in liters into number of chloride ions. Chloride ions are ionizable. Chloride ions ionizable. Gives the moles of AgCl. What is the molarity? Molarity is 0.2. Volume is 1.5. Now how many chloride ions it is giving? 2. So on simplification we get 2 by 10 into 3 by 2 into 2. Nothing but 6 by 10 means 0.6. 0.6 moles of AgCl is formed. Okay. Now in this one I explain once again. Since the coordination number is 6, so already it has 5 NH3, so one more coordination is filled by chlorine. So the chloride inside the complex satisfies both primary valency and secondary valency. The chloride inside the complex do not ionize. The chlorides outside the complex are able to ionize. So the N factor for this complex is nothing but number of chloride ions ionizable. So that is nothing but 2. So molarity into volume into number of moles of chlorides producing gives nothing but number of moles of AgCl. Now the next problem is how many moles of AgCl would obtain when 100 ml of 0.1 molar. This one is treated with AgNO3. Same problem. So again the complex is taken as CO surrounded by 5 NH3, or you take this time you take 4 mole. So 4. That's why what we expect coordination number is 6. So we take 2 more chlorines inside. Only 1 chloride is outside. You know this one ionize into. I repeat once again. The CO is surrounded by 4 NH3, whereas the covalency or secondary valency of cobalt is 6. Already 4 satisfied. That's why to satisfy 2 chlorides are inside the complex. Only 1 chloride is outside the complex. That's why when the complex ionizes, it produces complex ion and 1 chloride only. So in this case the N factor is 1. So how many moles of chlorides are available? Molarity into volume in liters into number of chlorides ionizable. Nothing but molarity is 0.1, volume is 100 by 1000 because taken in liter into 1 ion. Now on simplification we get 0.1 by 10 means 0.01 mole. 0.01 mole of chloride is available. So this can combine with AgNO3 to give 0.01 mole of AgCl. This is the completion of the problem. Thank you.